Welcome to Winsome Mathematics. In this video, we are going to learn gamma function. So beforehand, we have learned beta function. So if you haven't watched beta function, please check the description. Link is provided and go and watch it completely. Okay. So gamma function. First, we will learn that what is gamma function. Then we will learn another property of gamma function. Okay. So this function is more important because it is used to solve beta function further. Okay. So coming to the topic, we will see that what is gamma function. Okay, definition. So after covering the definition, you will understand that what is the significance of gamma function. Then we will understand another property. Okay. So coming to the definition, that what is gamma function. Gamma function, first point, that it is single variable function. Second point, it is used to solve complex integral. Third, factorial function. And fourth, now you will consider that what is written here, what is it. Okay, so we will understand each and everything. First, that it is single variable function. What are you understanding with it? Single variable, that means it is single variable, that is dependent on only one variable. Like in fx, like fx is equal to x square. This means what? That if we change the value of x, then the value of fx will be changed. Okay, like we put x is equal to 2, then this is equal to 4. If we put 3, then this is equal to 9. That means, like we are changing the value of x, we are changing the value of fx. So simply, if we will change the variable of gamma function, then the value of the gamma function will be changed. This means that this is single variable function. Okay, now second point, that it is used to solve complex integral. Like beta function, we used to solve beta function, we use beta function to solve complex integral. Similarly, we will use gamma function to solve complex integral. Clear? Okay, now you will understand, you will think that which type of complex integral. So we will cover it. Okay, wait, please wait. Third point, factorial function. What is factorial? You are familiar with factorial since childhood. Okay, factorial is simple. This is 2 factorial, 3 factorial, n factorial, m factorial. Okay, so this is factorial. And one thing to be clear from the factorial, that factorial gives you constant result. Okay, you will get the constant term at the end. Okay, so this is the importance, this is another most important thing, okay, inside the gamma function, because we are getting constant result. Okay, now fourth point is that this is second form of Euler's integral, and like beta function was first kind of Euler's integral, and this is second kind, just remember it. Okay, and now one thing also to clear, that Euler's integral is also a complex integral. Okay, improper integral you can tell. Now coming to the mathematical representation of gamma function, so that you will be more clear from it. Okay, now how does it look like and how strange, you will consider what is it, this is what, this is what, this is what. So okay, so we will clear it line by line. Okay, point by point. First thing, that this symbol is used to represent gamma function. Like whenever we come across this symbol further, okay, we will consider it as gamma function, symbol of gamma function. Okay, now what is an and this n you will see here n. Okay, here no, here no, here no, only n is written here. And where is it written? It is written to the power of x. Okay, and what is x? X is a variable of integration. Clear? What is n? N is written inside gamma function, and then you will come across n to the power of x. Okay, and n is not written anywhere else. Okay, only here to the power of x. And what is x? X is the variable of integration. Now think, like we used to identify beta function. How does it look like? Similarly, we will first be clear from its definition, mathematical representation. Okay, now here n is used to represent beta function. Like we will read it as gamma n. What? Gamma n. If there will be m instead of n, then we will read it as gamma m. Clear? Gamma p, gamma q, gamma s, gamma r, gamma t, etc. Okay, no problem. Now this n is here. If it will be m instead of n, then that m will appear here. Okay, so what do you mean with this? Like n is to the power of x, that means it is also a power function, that when we will change the power of x, then we will change the value of the gamma function. Clear? Very clear. Whenever we will change the value of the power of the x, then we will change the value of this gamma function. Like this is depending on the power of the variable of the integration. Now second thing to identify, that the limit is 0 to infinity. Always in the definition, the gamma function uses the limit 0 to infinity. Another thing coming inside the gamma function is that e to the power something, and whatever is in the power of e, that is written here. Okay, like here the power of e to the power of x. Okay, minus x, and minus is not only positive power is written here, e to the power minus x, then x dx. Like e to the power minus m, then dm. Okay, e to the power minus p, then dp. Now think to identify it. Okay, so this is clear now, that how does gamma function look like. Okay, so basically the conclusion was that this is single variable function, and whenever we change the value of n, we will change the value of gamma function. And where does n appear? Always n appear to the power of the variable of the integration. Okay, and the pattern is, again I am repeating, very clear. Like 0 to infinity, clear, e to the power minus x, x dx, minus p, p dp, minus m, m dm, minus n, n dn. And the power is what? Now to think, power is what? Power is n, then gamma n. Power is p, then gamma p. Power is m, then gamma m. Power is q, then gamma q. Clear? Okay, so conclusion what? That this is depending on the power of variable of integral. Okay, so clear. Now we will take some example to understand. Okay, what are you looking from this? What are you looking? You were thinking that this is also similar, this is also similar, this is also similar. Something is different, but almost looking similar. Okay, so this is example to be more clear. Okay, on the definition of gamma function. So first of all, we have to check that it suits on the definition of gamma function or not. Okay, if it does so, then we will identify the variable of the gamma function. And we all know that the gamma function is single variable function, and that variable always appears to the power of the variable of the integral. Clear? Okay, again I am repeating, that variable comes on the power of the variable of integral. So first of all, that check the integral is proper or not. Okay, so what is the form of gamma function? And the form is simple: e to the power minus x, x and minus 1 dx, and this is called as gamma n. Okay, now we have to match all the examples with this definition. Okay, first of all, that limit is 0 to infinity, limit is 0 to infinity, 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 0 to, all are proper. Okay, so nothing is confusion in the limit. Okay, now coming to the variable of the integration, like e always appears everywhere, e is appeared. Okay, now we have to check the power of e. Minus x x dx, similarly minus m m dm, minus n dn, minus pp dp. Clear? So we have to figure it out, like here minus x x dx, right, minus m m dm, right, minus p p dp. Clear? Minus pp dp. Clear? Minus x x, what is it? This is dn, so this is wrong. Okay, despite limit is right, but the integral is not in the form, so this is wrong. Okay, so here minus is missing, so this is also wrong. Okay, now here minus y dy, here now this is right, 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 this is right. As far as integral is concerned, as far as integral is concerned, and now we have to check that what is the power and what is there in the power. So because power is dependent, gamma function is dependent on power, so to figuring it out, we will compare it with n minus 1. Clear? So now n minus 1, n minus 1, so gamma n minus 1, n minus 1, gamma n, t minus 1, no problem, no problem, because this is similar, this is in the form of gamma function minus p p dp, and here gamma function doesn't depend on the variable of the integral. Okay, so don't confuse it that minus p p and here t, how can t become, how can n come. Okay, so don't confuse that, here m, here n, no problem. Similarly here p, here t, no problem, this is gamma t. Okay, now this is n minus 2, what is there in it? N minus 2, we will compare it with n minus 1, we will render it into the form of n minus 1. How? Simple. Think that how can we write it, n minus 1 minus 1. Okay, we can easily write it, suppose n minus 1 is x or p anything, then we can write it p and this is minus 1. Similar, if we will consider n minus 1 as p, then this is p minus 1. Okay, and the value is same, n minus 2, n minus 2, value is not changing, so you can write it p minus 1, that is gamma p, and p is equal to n minus 1. So similarly we can write it gamma n minus 1. No problem, no problem, there might not be any problem. Okay, now coming to the another problem, this is wrong, this is wrong, and this is n, only n, so we will also make it n minus 1. Okay, so how to render it in n minus 1? Now here we will plus 1 minus 1. Clear? Any problem? No. So simple, we can write it gamma n plus 1, and this is wrong, this is wrong. So I think that you must be clear with the definition of gamma function so far. Okay. So now to tell the importance of gamma function. The importance is that all gives you the factorial representation and all comes with the constant output. Okay. And this gamma function is also used to solve beta function. Okay. Because beta function ends as beta m and we will solve m and by converting m and n into gamma function. Okay, so we will study the property of gamma function, second property. So coming to the property of the gamma function, and first property is recurrence relation. And what is the meaning of recurrence relation? So first of all, clear it. Okay, recurrence relation is something by which we can represent the nth term as a relation of the previous terms, like we always write nth term in the relation of the previous terms, like n minus 1, n minus 2. Okay, that what comes before n is used to represent n, like we can represent n in the form of n using recurrence relation. Simple. So we will understand that how we represent it inside gamma function. Okay, so first of all we evaluate gamma 1. What is gamma 1? Okay, so clear. So must clear it. Gamma n is equal to 0 to infinity e to the power minus x, x to the power n minus 1 dx. And one more thing to clear, that what is the value of gamma function, and this is equal to n minus 1 factorial. So this is the importance that I will repeating continuously, that what is it? This is factorial function. So whenever we get the value of n, we can easily tell that this is n minus 1 factorial. If it is 6, then 5 factorial. If n is 7, then it is 6 factorial. N is 8, then it is 7 factorial. Okay, so simple. Now coming to the recurrence relation. So first of all, we will evaluate gamma 1. What is gamma 1? Gamma 1 is equal to 0 to infinity e to the power minus x to the power 1 minus 1 dx. Clear? Any doubt? No. And we simply put 1 instead of n here. Okay. Now we can easily write it 0 to infinity e to the power minus x and x to the power 0 dx. And what is the integration of e to the power minus x? Simple, minus e to the power minus x and to the 0 to infinity. E to the power t is e to the power t, e to the power x is e to the power x, so it is minus x. We will consider it as t. Then what is it? Minus x is equal to t, so x is equal to minus t dt. Simple. And minus will come outside the integration, and e to the power t is e to the power t. What was t? T was minus x, and minus is outside the integration, so minus e to the power minus x. Clear? Now if we will evaluate it, minus e to the power minus x e to the power infinity, what will we get? Simple. Minus will be come outside the bracket, e to the power minus x, that e to the power minus infinity minus e to the power 0, and e to the power minus infinity is what? 1 upon e to the power infinity, and 1 upon infinity is 0. 0 minus 1, that is minus 1, and minus minus 1, that is plus 1. Clear? Like we can write 1 upon e to the power infinity minus e to the power 0, that is 1. Infinity, it is also infinity. E to the power infinity, something to the power infinity, is also infinity, so we can replace it with infinity. Clear? Now 1 upon infinity is 0, and 0 minus 1 is minus 1, that is minus minus 1, that is 1. So 1 is the value of gamma 1. Okay, so clearly we can tell that gamma 1 is equal to 1, and it must remember it. Also we can solve directly that gamma 1 is equal to 1 minus 1 factorial, that is 0 factorial, and 0 factorial is equal to 1. Clear? So but this is a derivation, and why am I doing it? Because to be more clear in the recurrence relation. Okay, now understand that what is recurrence relation. Okay, recurrence relation tells us that gamma n plus 1 is equal to n gamma n. Clear? That whenever we come across gamma n minus 1, that is 6 plus 1, we can easily compare it with the gamma n plus 1. Okay, and n is equal to 6, we can easily write what is it? N plus 1, 6 plus 1, then 7, so we can write 6 gamma 6. That means gamma 7 is equal to 6 gamma 6, gamma 8 is equal to 7 gamma 7. This is the benefit of gamma recurrence relation. Okay, now understand that how to prove it. Gamma n plus 1 is equal to 0 to infinity e to the power minus x n plus 1 minus 1 dx. Any problem? Gamma n is n minus 1, so gamma n plus 1 is equal to n plus 1 minus 1. You can also change the variable of the integration, no problem. Minus p no problem, you can take. But we are familiar with x, so we are taking it as usual. Okay. Now what is it? 0 to the power infinity e to the power minus x to the power n and dx. Plus 1 minus 1 got cancelled. Okay, both are four of each other. Okay, plus 1 minus 1. So now e to the power minus x to the power n, we will simply do the by part here. Which term we will consider as first function and which second function? Simple. Whose derivative is simple? Simple as compared to the second one. Whose derivative is simple? And whose integration is simple? Whose integration is simple, we will take it as second part, and whose derivative is simple we will take it as first part. Here derivative is simple of both, but integration is simple of e to the power minus x as compared to x to the power n. Okay, so we will take this as second part and this as first part. Also according to the Euler rule, E comes after trigonometric expression, okay, and algebraic expression. So A x is algebraic expression and E is exponential. So we will take it as first function, it as second function, and the logic was similar behind that. Whose differentiation is easy, we'll consider it as the first function. Okay, now by using integration by part, we can easily write first function into integration of second function, that is minus comes outside e to the power minus x, okay, and this is integral 0 to infinity derivative of the first function. What is the derivative of the first function here? Derivative of the first function is x to the power n minus 1 into n. Any problem? This is a simple formula. Okay, and now e to the power minus x is minus e to the power minus x, and minus is multiplied, so minus minus becomes plus. Okay, and we can easily write it e to the power minus x. Now something must be clear to your mind, must twinkle in your mind, that what is it? N is constant, n is in the power of x, not variable here. Okay, so we can easily take n outside the integration. Okay, and now how does it look like? How does it look like? It simply looks like gamma n. This is the definition of gamma n. Okay, and now after solving it, we can easily evaluate what? Recurrence relation, that n gamma n plus 1. We will compare LHS and RHS. So see. So we can also put the limit one by one. Okay, here all limit 0 to infinity. So here if we do 0 to infinity, okay, here 0 to infinity is cancelled, here 0 to infinity. Similar, simple, because the limits are just transformed by part. Okay, now 0 to infinity, when x becomes 0, then this all terms becomes 0. Clear? When this becomes infinity, x becomes infinity, that e to the power minus infinity, that is 1 upon e to the power infinity, this is 0. That means both terms are cancelling each other. 1 infinity making this 0, 0 making this 0. That there is no importance of this term, and this is cancelled. So this is simply is equal to n, and this is the definition of gamma n. So we can easily write gamma n plus 1 is equal to n gamma n, and please note it down. Okay, and this is the important relation. By this relation we can also solve the fraction inside the gamma function by knowing the value of gamma 1 by 2. Okay, now we will consider it, that what is the benefit of this. Okay, now please note it down. So now what is the importance of this? We know that gamma 1 is equal to 1, clear, and gamma 1 by 2 is equal to root pi. Okay, just remember it. Now we will also see the proof of gamma 1 by 2 when we will see the relation between gamma and beta. Okay, then we will solve it. Okay, so let it be now. So just remember it, that gamma 1 by 2 is equal to root pi. Now with the help of this recurrence relation, we can also find the gamma 3 by 2, gamma 5 by 2, gamma 7 by 2, gamma 8, gamma 9, everything. Like I am telling you gamma 2. What will you tell? What will you tell? You will simply tell me that we can adjust it into the form of n plus 1. How? So simple, 1 plus 1, and plus 1 is similar, plus 1 is similar. What is the value of n? That is 1 here. We can also write it 1 gamma 1. That is what? 1 gamma 1 is what? 1 into 1, that is 1. Simple. We can easily write gamma 3. Gamma 3 as 2 plus 1. Okay, simple. simple is the thing. Okay, so we can also write gamma 6 as gamma 5 plus 1, so we can easily write 5 gamma 5. This is also 2 gamma 2. Now you will tell me that we can also solve it by simple, that gamma n is equal to n minus 1 factorial. But how does it come? It can also be compared with the recurrence relation. Simply you can write gamma n as n minus 1 plus 1. Simple. Simple, this is the term. So this is n minus 1 gamma n minus 1. Okay, you can also write it as n minus 1 gamma n minus 1. What? You can write gamma n as n minus 1 gamma n minus 1. This is also representation. And we know that gamma n is equal to n minus 1 factorial. You can easily tell gamma 2 is equal to 2 minus 1. That is 1. 2 minus 1 factorial. 3 is equal to 3 minus 1. That is 2 factorial. That is 2. 2 into gamma 2 is equal to 1. You can also tell gamma 6 5 minus 1, sorry, 6 minus 1, that is 5 factorial, and 5 factorial is equal to 120. You can also evaluate, but what will you do when fraction will be considered? Simply like gamma 1 by 3 by 2. Now you will write it 3 by 2 minus 1 factorial. It is right, that is 1 minus 1 by 2 factorial. Do you know the value of 1 by 2 factorial? We know it, no. Fraction factorial always takes the positive, not rational value. Rational but not fractional. Okay. Rational is also 6 by 1. But we don't consider 1 in the denominator. So both all are rational but must not be in the form of fraction. Okay. So when fraction comes, whenever we come across the fraction, we have casualties. So we can easily solve it by using recurrence relation. This is the importance. Okay. So now we will see that some common fraction that it comes inside gamma function always. Now, how to tackle this question? Simply we will consider that this is 3 by 2, this is 5 by 2, and this is 11 by 2. Now you will think that we can write gamma 3 by 2 as 1 plus 1 by 2, gamma 5 by 2 1 plus 3 by 2, gamma 11 by 2 1 plus 9 by 2. Clear? Simple. 2 plus 9 11, 2 plus 3 5. Okay, so simply we can write it, but we only know the value of gamma 1 by 2, not gamma 3 by 2, not gamma n by 2. Then how to solve it? So simply first we will solve 3 by 2. What does it come out? And that n plus 1. Then what is the value of n plus 1? That plus 1 is clear. Plus 1 is clear. And what is the value of n? 1 by 2. Here 3 by 2. Here 9 by 2. Clear? So we can easily write that is 1 by 2 gamma 1 by 2. Here we can write 3 by 2 gamma 3 by 2. Here we can write 9 by 2 gamma 9 by 2. Clear? So we know the value of gamma 1 by 2. So we can easily write 1 by 2 root pi, and we will cheer it out like we have find out the value of gamma 3 by 2, but not in case of 5 by 2. How will we solve it? So we will put this result here directly. Whenever gamma 3 by 2 comes, we can put the result 1 by 2 root pi. Simple. No, if you are having casualty by remembering this term always, like gamma 3 by 2 is equal to, so simply we can again convert 3 by 2 gamma 1 plus 1 by 2. Simple. We have to do it as far as 1 by 2 doesn't come. Okay, so simple. 3 by 2 into 1 by 2 gamma 1 by 2. Now we can write 3 by 4 and root pi. Clear? Because we know the value of gamma 1 by 2. So here also we will extend it. 1 by 2 gamma 1 plus 9 by 2, sorry, gamma 1 plus 7 by 2. Now 7 by 2 gamma 7 by 2. Simple. What is it? This is what is the value of n here? 7 by 2. Compare it with and n gamma n. That means 7 by 2 gamma 7 by 2. Clear? So 9 by 2 multiplied with 7 by 2 gamma 7 by 2. Now you can write 7 by 2 as 1 plus 5 by 2. That is 9 by 2 into 7 by 2 into 5 by 2 gamma 5 by 2. Okay. 9 by 2 here we can see 9 by 2 into 7 by 2 into 5 by 2 gamma 5 by 2. Now 5 by 2 can be written as gamma 1 plus 3 by 2. Simple. And we will again write 5 gamma 5 by 2 as into 3 by 2 gamma 3 by 2. And then we will convert 3 by 2 as into 1 by 2 gamma 1 by 2. Then we will solve it and we will get the result. And this is the importance of gamma function. Now we will think that why are we considering fraction? We will consider that what is the importance of the fraction inside the gamma function and why are we studying it. So simply I will tell you with example of beta function that whenever you come across beta 4 comma 5, when you will study the relation between beta and gamma, you will come out as a result that gamma n upon gamma m plus n. Here you can solve 4 5 9. You can easily solve 4 gamma 4 is equal to 4 minus 1 factorial, gamma 5 is equal to 5 minus 1 factorial. But when you will come across beta 3 by 5, like 3 by 2, 4 by 2, 7 by 2, then you will understand the importance of this fraction inside gamma function. So this was the basic lecture of gamma function and I have covered each and every topic relevant to the gamma function. Okay, so after this you won't have any casualty in the further topics of gamma function. Okay, so thank you for staying so long and this was the first lecture of gamma function. So I hope you enjoyed it.